Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.107. While solving this problem, we will be using delta to star configuration conversion. Here is the list of formulas which will be used to convert a delta connection into an equivalent star connection. Now move towards the problem. Exercise problem number 2.107. Find the power supplied by the 24-volt source in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find total supplied power through this 24-volt source. So without wasting time, let's proceed towards the solution. If we observe in the statement, it is asked to calculate total supplied power through this 24-volt source. For that purpose, we should have total equivalent resistance of this network. Then we will use the power formula, that is P equal to V square divided by R, and in place of R we will place R equivalent of complete network. So in order to calculate total supplied power through this 24-volt source. But before that, we have to find the equivalent resistance of this complete network. For that purpose, we will start simplifying this network to find a single resistance which will be equivalent of this network. Start from here. These two resistances of 12 kilo ohm are connected in parallel connection. So we can find their equivalent resistance and replace a single resistance with these two resistances. In this scenario, both resistances that are connected in parallel connection have same amount of resistance. So their equivalent resistance will be calculated by dividing the value of a single resistance with the number of same parallel connected resistances. R equivalent will be equal to 12 kilo ohm divided by 2. So R equivalent will be equal to 6 kilo ohm. Now we can modify the network by replacing these two resistances with a single resistance having the value of 6 kilo ohm. For further simplification of the network, we have to convert these three resistances that are connected in delta configuration into star configuration. For that purpose, we will place a star connection inside this delta configuration. This is a star configuration which is placed inside this delta configuration, and we are interested to calculate the values of these three resistances in star configuration labeled as RA, RB and RC. We will use these three equations to convert delta into star. For that purpose, we have labeled these three resistances as resistance R1, R2 and R3. Now in order to calculate RA, we will multiply R1 and R2 together and divide with the sum of these three resistances. RA will be equal to 12 kilo ohm multiplied by 12 kilo ohm divided by the sum of three resistances connected in delta configuration. So the value of RA will be 4.8 kilo ohm. Similarly, RB will be the product of R2 and R3, 12 kilo ohm and 6 kilo ohm divided by the sum of three resistances. So it will become 2.4 kilo ohm. And same case will be with for RC. RC will be equal to product of R1 and R3 divided by the sum of three resistances. It will also be 2.4 kilo ohm. Now we have calculated these three resistances that are connected in star configuration, and this star configuration is equivalent to this delta configuration. So we can replace this delta configuration with equivalent star configuration in order to simplify the network. Now we will modify the network by replacing delta configuration with star configuration. Now these two resistances and these two resistances are converted into series connection. So we will find their equivalent resistance by adding the values together. R equivalent of this series connection will be the sum of 2.4 kilo ohm and 12 kilo ohm. It will become 14.4 kilo ohm. And same value will be the equivalent resistance of these two resistances because both have identical values to these two resistances. So their equivalent resistance will also be 14.4 kilo ohm. Now we will modify the network by replacing these resistances with their equivalent resistance. Again, these two resistances are converted into parallel connection and both have same values. So we will find their equivalent resistance by dividing the value of a single resistance with the number of resistances connected in parallel connection. So their equivalent resistance will be equal to 7.2 kilo ohm. Modify the network by replacing these two resistances with a single resistance having the value of 7.2 kilo ohm. At this stage, this circuit is converted into a simple series network. We can find their equivalent resistance by adding the values of both resistances together. Their equivalent resistance will be equal to the sum of both resistances, that will become 12 kilo ohm. So now we have a single resistance of 12 kilo ohm connected across 24 volt, and this 12 kilo ohm is the equivalent resistance of complete network. So we can calculate total supplied power through this voltage source using this equivalent resistance of complete network. For that purpose we will use power equation V square divided by R. In this case V is 24 volt, so take its square and R is replaced with the equivalent resistance of the network, that is 12 kilo ohm. So the value of total supplied power through this 24 volt source will be 48 milliwatt. So this was exercise problem number 2.107. Thank you. See you again in next video.